Hello everyone, welcome back to another YouTube video here at Becoming a ROS Developer. My name is Rodrigo and today we have one of our students, Richie, who has completed the course ROS 2 Navigation in 5 days. And at the end of this course, you can present this project and it's implemented on a real robot. So that's what we're going to be seeing here today, an autonomous navigation application on a real robot. Presented here by Richie. So hello, Richie. How are you?
I'm good. How about you?
I'm good. Thank you. Very excited to see your presentation that I see that you're already presenting, which is great. So whenever you want, please go ahead.
Hey, hello. So I'm going to present my ROS2 navigation in 5 days, my progress and what I did. So in this test, we are tasked to do, first we need to map a robot to create the map. And then after that, we can save that map for other purpose. For this, we can use it for localization. And then after we localize ourselves in the map, we can make our robot move to a set point target. As you can see here, in my presentation, we already have a map, and at first I set the initial position wrong, and then by moving around the robot and getting the sensor data, it can position itself correctly. This is from the simulation. I will show you later how I do it in the real robot too. And this is just a small demo in this simulation where I pick a 2D goalpost and the robot can move by itself. It will choose the shortest path in general. And I'm not sure what algorithm it is. Maybe I think it's A-star, I've heard.
Either that or Dijkstra, which are the two default ones.
Yeah, so this just shows it. And then later we can save this spot recorder to some list using YAML, and then we can just call that spot, and the robot can move by itself, like shown here. But I think that this can be skipped. I just want to show you because we can see it later in the real robot.
Awesome.
So I'm going to show you.
Yeah.
And what I think about this application is why we want this, why we want to save a spot, or why we want to send some command to the robot. Like in my university, there's this Starship robot. You can put restaurant put food in it, and they just deliver it directly to the person autonomously. Well, that previous one is a good demo, and this is a good demo to show what that thing is capable of. You can just give it some food and give them some spot in the map, and they can just move by themselves. The difference is they don't need to set initial position because they are using absolute coordinate using GPS, I think, and some camera to do obstacle detection. Yeah, so I think this is a good demonstration that the navigation can do. Now I'm going to change my screen to the robot. Yeah. Can you see my screen?
Yes, we can see the robot now and Arvis and the turtle.
Yeah, so I already launched the program and the Arvis.
Great.
Oh, crap. Yeah, I'm going to make it bigger for you guys so you can see. Yeah, so I already started it. I haven't localized it, so we can do it together.
Yeah, great.
I already set the initial position by the way, so yeah, but it's clearly wrong. So I just spin it around. Well, like I think spinning around is a good idea because I think that's why they use it in their
it's just the fastest way, to localize.
Yeah.
And I can see it's localizing correctly even if there's that obstacle out of place, so it's seeing that but it's still able to localize. Nice.
Yeah. So after this, I can give it the goalpost. I'm not sure why this thing is not showing the robot model, but I'm pretty sure it's around here. So yeah,
For
it's
that,
going to
you
go
would need
here.
to turn off the TF element, and you'd be able to see it where the robot is. The robot model, sometimes it doesn't work that well because it's an extra step, but yeah, it's adding TF.
Yeah. So yeah, it can move like before with the 2D goalpost.
Mm-hmm.
And then after this, we can send the our safe spot. Let's do that. This is for corner one.
Where's that at? Where it's going, I guess.
Yeah, it's here. And this is
Uh-huh.
corner two, and pedestrian is here. I mean, like even if the map isn't completely correct, like you said before, I think it's able to localize itself pretty good.
Yeah, because it has so many data points to go off of.
Yeah. Oh, it's already arrived. And we can use corner two. Should go here. You can see my cursor, right?
Yes, yes, I can see it.
Uh,
Seems like
oh, what? Stuff.
maybe it's stuck. Huh.
Why is it?
Looks like we literally just had an issue
Oh yeah.
with the robot.
Oh yeah. I think the ROS stopped too. It's not updating.
Oh yeah. But don't worry.
Well, but
I
you
saw
see
the
the ID,
first one.
right?
Yes, yes. So while you wrap up here, do you mind disconnecting from the robot and trying to connect again to see if that's the issue?
Oh yeah.
All right, cool. But I saw basically that you set up their navigation, sent your goals to make sure nav2 was correct, and then used a program that I saw you sent, corner one.
Yeah.
And could you now sort of like tell us how you did that corner one? Like, how was that able to translate to a coordinate and actually go there?
So basically, using ROS, I first put the goalpost there, like set, and if we in ROS,
Mm-hmm.
where's the when you set a goalpost in the terminal, it shows you which point you send that goalpost to.
Yes.
Yeah, and then just save that in the YAML file.
Do you mean the goalpost or the initial position?
The goalpost. I mean, I think ROS like have some post stamp in it, and it can just what do you say? Mm,
Could you show us that file? That is subscribing to that and then putting in the YAM?
yeah.
Um, all right, cool. We'll give it a second while it loads. And if it doesn't work, don't worry. Maybe because we had like 5 presentations back to back from the University of Houston. Shout out. Thank you so much, Houston, to be using our services like this.
Yeah. Uh,
The spot recorder, yes.
yeah. I mean, yeah, I can just call this and save some spots,
And what are you
and
subscribing to?
post post with covariance and stamp mint.
No, but what
It's just
topic? Initial pose.
uh, uh
Yeah, I
yeah,
can see it.
initial, yeah.
All right. So what does this mean that you have in line 17 5 spots already? What does that mean?
This is just like how many posts that I can see.
How many what?
Spots.
So in terms of ROS clicking, that means what is the I'm sorry, what is the order in which you launch this program and then save those coordinates? So you would do what? First you would run this, right? You run this spot recorder, then what do?
Wait, let me open the ROS. I forgot.
Yeah, let's see.
I publish a poem.
You publish a point. Okay. But no, you don't. You actually do initial 2D post estimate. Yeah.
2D post estimate.
What I'm trying to get at is that you can only do 5 spots here, right? And they're going to be called all the time corner 1, corner 2, pedestrian, spot 4, and spots. So you would need to first click the initial post at corner 2, right? So that would be corner 2, and corner 3. What happens if you do more than 5 points? Doesn't get saved, right?
Yeah.
Okay. Yeah. And then how do you take those spots and send them over to your client?
I'm using the navigate to post.
And how do you read those coordinates?
I first read the YAML file that I save in here.
And
and then just I publish it to the the ROS one is move base here.
Yeah, this is just like nav2. You can call it nav2.
Yeah.
Okay, and you're using parameters. Nice. So you are avoiding reading the file directly, and you're loading up those parameters, which is nice to see. Cool. All right. Though I'm sorry to interrupt. Those are actually all the questions I have for you, Richie. Let's see if that fixed it. Yeah, it kind of fixed it. Nice. So maybe we can see just another spot.
Okay,
yeah.
I think I need to launch this again.
Yeah. So you launch your localization. So as soon as you click this, yes.
Roughly
right there, actually. Yeah. Facing down. Yeah. Good spatial awareness. Okay.
I need to move it around.
You don't need to. It's well enough already. It's going to fix itself. Well, yeah, we did corner 1 already, right? Yeah. Awesome. So now it goes to the coordinates that you set on the other side. Looks like your tolerance is quite big. I would bet it's 0.25, isn't it?
Yeah, I think. Yeah, I think.
Great. All right. Awesome. So did you send another one? Oh, you're moving it out of the way.
I'm moving it out of the way.
Okay.
I did realize this is in the simulation at least. Like if your robot is too close to the obstacle, the LiDAR cannot see it, and that's bad.
Yes, it will show up as infinite, but if you're running nav2 on top, it would not even consider it. What you would consider, though, is that you're on top of an inflation layer, so it would kick in and a recovery behavior right away. That's what would happen. Awesome, Richie. So congratulations, really nice project. So let me give you an applause. Really nice explanation, and I really loved your comparison to what you guys have in your campus, which is amazing. I've never actually seen that over in Spain. We don't have those robots yet running around delivering food. But let me ask you, because that's a really interesting thing. So, and you mentioned a difference, right? You mentioned that it uses GPS, right? So what's basically the other difference between your navigation setup and that robot navigation setup?
So I think one of the biggest difference is for our localization, we use LiDAR, I think, and they use a stereo camera to localize themselves and
Okay.
to do obs.
But localize themselves with respect to what?
So I think they already map the entire university with, I think, probably more advanced robot than that.
Yeah, that's the point.
And
I don't think they have. They're actually, that's the difference between outdoor navigation. This is a different topic almost, but so I don't think. I mean, maybe they have, but that means they can't navigate outside of that university, and it's really hard because, like, how do you map? Let's say you're outside, you're using the lidar. How do you map something that is not returning to you? So, like, it uses basically, the lidar is like a bat, you know, it's sending out signals and they're returning. That's the distance, right? But let's say
yeah,
your range is 10 meters and you're outside and everything else is 50 meters away for it to bounce. So it wouldn't work. You couldn't be able to build the map the same way you do here because everything is
yeah,
contained. So my guess is that those robots actually use either simultaneous mapping and navigation. So if you were to look at it in Arvis, right, it wouldn't be a whole map. It would just be like looking out, and then as it moves, it can continue making the path, and the local planner avoids obstacles and things like that. And you have the final coordinates with the GPS. So I think my guess is they don't use a map at all. They do everything based on coordinates because that guy has a GPS, and basically the global path here would be a straight line, which then gets can be tuned by the fact that they're streets, so you can tell, take a street, don't go across on the yard. So that very interesting that you mention it because that is a big step forward. In order to implement outdoor navigations, you have to do things that are different than indoor navigation. It's more complicated for sure.
yeah, and I think because of the GPS, they don't need to concern themselves much about sensor noises.
Well, no, but they have a difficult scenario too because, for example, if you use GPS and then you go under a bridge or something, you're gonna lose that GPS. So what some people do is kick in another type of tracking. For example, if they have a camera, once they lose GPS, they'll be like, all right, where was I right before I stopped knowing where I was GPS? Okay. And then they use, for example, visual odometry. So they use frame differences to kind of continue until they have GPS again. But anyways, Richie, thank you. Very, very nice presentation. And now we've seen everything that you can do with NAV2 on a real robot. So I want to thank you and congratulate you again, Richie.
Thank you.
All right. Let me just switch my camera here. And yes, to whoever is watching, this is what you can do when you take our course, ROS2 Navigation in 5 days. You can set up and implement a NAV2 stack and some applications on top on an actual real robot. So I invite everyone to keep pushing your ROS learning and to hear what Richie did and come present your projects. Thank you very much to everyone, and we hope to see you for the next time. Bye-bye.
Bye-bye.
All right, cool, Richie. We're done.
Oh, thank you.
Right on.